So we're back working on this 2011 Aveo with the thermostat housing. Here's the dormant part number 902033, and it's cast aluminum instead of injected molded plastic, and it comes complete with the thermostat, which I'd already bought and replaced. Hopefully can return it. And here is the radiator cooling fan resistor for the low speed. This is an AC Delco part, and as I mentioned before, it looks like a ballast resistor from the 70s. Probably had a few million of them in some warehouse in Arizona that needed to be used up. But nevertheless, we're going to put in this thermostat housing and the resistor and refill the cooling system and run it and see that the cooling fan now works on low. So there's the thermostat housing off. There are 4 E10 bolts that hold it to the cylinder head, 2 hose clamps, 1 temp sensor with a snap ring. I see it comes with a new temp sensor by the looks of it, but I don't think that's a temp sensor. It looks like a temp sensor. I'm going to have to look and see if there's terminals in there. Doesn't look like there's terminals in there. And there's a quick release, not so quick release, quick connect fitting at the top that you have to manipulate with a couple of picks to get off. 2 T30 bolts in the bottom here to a coolant bypass pipe. And I'm not sure what it's got on here for a gasket, because there's no gasket on the front of this thing. I wonder if there was an O-ring and it fell out. Or maybe there's an O-ring in here. Yes, there is. There's an O-ring seal in here. Did not come with that O-ring. Okay, and it's a square O-ring, so I can't use the universal one. Okay, well, we'll see if we can reuse it. So if you remove the left headlight, it gives you easy access to that resistor. There's just 3 bolts, 1, 2, 3 bolts, and the headlight comes out. Disconnect the electrical plugs. Now this stupid resistor is held in here with 2 Phillips screws, and because of their corrosion, they're not coming out. So I'm going to have to cut the wires off and solder new eyelets on the end of the wire, because this thing is not going to be able to save it. So I had to lengthen one of the wires because it was all burnt, as you can see here. I don't know why it was burnt like that, but nevertheless, there's the old resistor. Can't salvage the screws. And guess what? The new resistor doesn't come with screws. So fortunately I found a couple of screws that are the right thread pitch, but they're too long, so I'm going to have to cut them off, because you can see they only go in 1/8 of an inch. So something as simple as supplying 2 frickin' screws with this new part would have been a no-brainer, because I can't use the old ones. I did find 2 screws that fit in there, but they're not 832, they're metric. So I have most of these pliers will cut machine screws, 832, 1032, and so on. I have 1 pair of pliers that has the cutter for metric 4, as you can see here, but because they're Chinese, I shouldn't say that, because they're cheaply made, they don't go, the screw doesn't screw in there properly. And that's the only pair I have. I have 5 pairs of wire strippers of different brands, and only one of these, the Westward ones, has a metric screw cutter. So, took my pliers apart, drilled that hole out slightly larger, and now you can put the screw in and cut it off. I estimate that should be long enough. Maybe I'll thread it out a little bit more. This is a hidden feature that a lot of these pliers have that a lot of people don't use. And when you cut it like that, it shears off. And then when you back the screw out, it fixes the thread. That's the critical part, that you put the screw in the right direction. All this could have been prevented if the cheap part suppliers would have supplied new screws with it. Lucky I had some 4mm screws. So that's it. We'll put this on. So there's the resistor back installed. I put some battery post sealant on the terminals, try to keep them from corroding a bit. Thermostat housing's installed. A little silicone grease on all the seals. I have to secure this heater hose. Cooling system's full, or semi-full, so we're going to run it and see what temperature the thermostat opens at, and also what temperature the cooling fans run at. Before I run this, I'm going to try and command that cooling fan to run. If you watch the first part of this video, cooling fan relay clicked on, but it did not run the cooling fan. Now it's running. And it's running through that dropping resistor. So that resistor is going to get quite warm. But it's a poor design. There's a lot of other ways they could have done this without running it through a dropping resistor. But nevertheless, that's what they chose to do. So we're going to look at some data parameters here. Coolant temperature. One of these should show the status of that cooling fan. Cold startup, desired idle speed, intake air. AC relay. I have to look for it. So it's actually in the accessory electrical theft data list. So it has a bunch of data parameters related to temperature. Desired coolant temperature sensor in the radiator, intake air, coolant temperature sensor in the engine, which we ended up changing. That was a new sensor in there. Fan control relay for low speed and fan control relay for high speed. So we're going to start it and run it. So it's been running for about 10 minutes. I reinstalled the headlight while it was warming up. It's up 176. I'm going to try turning the AC on and see if that cooling fan runs on low with the AC, if the AC actually works. So as you can see, the low speed cooling fan runs with the AC compressor turned on. I'm going to turn it off again. It'll likely run it for a few more seconds. Yes, there it goes. So shut it off. So that dropping resistor would have affected the performance of the AC as well. Created high AC pressures. So his AC may function a little better now than it did before as well. So this thing's been running for about 16 minutes now, and unless you rev it up, you won't get it to come up to temperature. It's climbed to as high as 210 and then dropped back down to 203. Thermostat opens at 105 Celsius, which is 220, roughly 222. You see desired temperature here of 222 degrees Fahrenheit, which is a lot hotter than things used to run. But they're trying to raise the thermal efficiency of the engine by making it run hotter. And if it's designed to run that hot, then that's fine. I'm curious as to when this relay is going to be commanded on, and if it's based on radiator coolant temperature. The rad is still cold because the thermostat is barely open. Well, the thermostat's definitely open now because you can see the radiator coolant temperature is climbing significantly. It's running at 219 Fahrenheit, and it's been running for about 29 minutes. I got the throttle running at about 1500 RPM. So now we got radiator temperature of 204 Fahrenheit, and it just commanded it on at 204. So we should start to see this temperature drop now with the cooling fan running on low. There it goes, 203, 201, 199, 197, 195. If you ever there, so it commanded it back off at 195 or 194. So we'll call this one fixed. Now we got to do the power steering problem.